Today's video is going to be on finding extrema, maximums and minimums, on a closed interval. And we have our function 1/3 x cubed plus 4x squared plus 12x plus 3. And the interval that we're going to look at is the interval from the closed interval from -3 to -1. Now, this is a step-by-step process, a checklist. So 1, find f prime of x. So the first thing we do is calculate the derivative. Remember, find doesn't mean say, oh look, there it is. It means calculate. So I should probably write calculate, but for right now, just go with find. So f prime of x is going to be 3 times 1/3 x squared plus 2 times 4x plus 12. And so f prime of x is going to be 3 times 1/3 is 1. So I get x squared plus 8x plus 12. Now, step 2 says set f prime of x equal to 0 and then solve for x. And what this is going to give you are your critical values. So I'm going to take f prime of x, set it equal to 0, which means x squared plus 8x plus 12 is equal to 0. And now I have to factor, and I need two numbers that when I multiply them, they equal 12, and when I add them, they equal 8. So I believe 6 and 2 will work. So I'll get 6 and 2. So I'll get x plus 6 times x plus 2 is equal to 0. If I use the zero product property, x plus 6 will equal 0, so x is equal to -6. X plus 2 is equal to 0, so x is equal to -2. So my critical values are, we'll go C1 is equal to -6, C2 is equal to -2. So far we've taken a derivative and set it equal to 0 and found the x values that will make that work, and these are going to be our critical numbers. Step 3 is we're going to make a chart. So make the following chart. We're going to put left endpoint, and I apologize for that not being good. C1, C2, and you can put as many as you need, and then the right endpoint. And we're going to put, since we're on the interval from -3 to -1, the left endpoint in this value, these are our x values. This is going to be a -3. C1. Now I look at these two values and I say, alright, which one is, if I look at the number line, I'm going to go from -3 down to -1. So I only want values that are here. And the only one that works is -2. So I'm going to put a -2 there. I don't need this one, so I can just kind of cross it off if I want to. And the right endpoint is going to be -1. Now I want f of x. I want to evaluate the original function at these values. So I'll get my calculator. Or you can do this in your head if it makes it easier for you. For the sake of brevity, I will grab the calculator, move move this over a little bit. And the original function is 1/3 times, I'll take -3 and I'm going to cube that, plus 4 times -3 squared. Make sure I have all my parentheses in the right spot. Plus 12 times -3 plus 3. And for the first value, I calculated, well, let's see if I go over here, that might be a little bit better. I got a -6. So I got a -6. Now I'm going to go in and replace all my -3's with a -2. So I'm just going to hit Control Escape, jump back up here, delete that, put a 2, delete that, put a 2, delete that, put a 2, and I get -23 over 3 which is equal to -7.67. And now what I want to do, I had to get the decimal from there. I am going to jump back up into the calculator and put in x is equal to -1. So I have to hit Control Escape, then Control Escape again, Control Escape, Control Escape, Control Escape. Now I'm back at the original function. I need to put a -1, delete, put a 1, delete, put a 1, delete, put a 1. Now, however you're comfortable doing it, I just like to kind of go back and rewrite or just substitute in the values for whatever I do. Then I get a -16/3, which would be, if 3 goes into 16 5 times, we get to 15 with 1. This is a -5 1/3, so 5.3 repeating. This is really equal to -7.6 repeating, and that's equal to -6. So we got our values here, and in class I'll show you, or I'll make another video on how you could actually use a table in here to calculate the values instantaneously. Now, what we have to do is we have to pick out of these three values what's the highest point possible, the biggest value. And since they're all negative, the smaller the negative number, the higher the value is on the number line. Because remember, on a number line, 0, -1, -2, -3, the smaller the negative number, the more right it is, which means the bigger the number. The smallest negative number is right here. This is going to be my relative maximum. And the bigger the number is that's negative, the smaller it is. So that's going to give me the most minimum number on the interval. This is going to be my relative minimum on the interval itself. Now, notice here that I got a maximum at the end point, which is what we have to be really careful about. And I got a minimum at the critical value, and this guy just didn't really play into it. If you would graph this, you would kind of see the interval. And let's go ahead and graph this on the interval. Alright, so I'm going to introduce a graph, and I'm going to put 1/3 x cubed plus 4x 4x squared plus 12x plus 3. And here's my wonderful graph. And what I want to do is I'm going to go to my window, and I want to use window settings, because I want my minimums. I'm going to go -4, and then I'm going to tab down and go 0. So that's going to contain my interval. Let's move in a little bit and hope the screen doesn't freeze up on us. So that's going to contain my interval from -3 to 1. And remember, the interval is always your x values. Our numbers for our minimums here, we had -5, almost -8, -6. I'm going to put my minimum at 0, and my y minimum at -10, and my y maximum at 0, so we can kind of get a good picture, and we'll change it if we have to. Then I'm going to hit OK. And so here's the interval. And if I go to point on, we can see the interval a little bit better. So I will go to geometry, points and lines, point on. I'm going to open up. Oh, first you got to choose the graph. Then I'm going to open up this and say I want -3. And there's my first point. Then I'm going to choose the graph again, and I want all the different points. I want -2. And then I'm going to choose the graph again, and I want -1. So this is the interval. I plotted the two endpoints. That was the first endpoint. That was the second endpoint. You can see that this is the maximum value, and you can see that this is the minimum value. So on the graph itself, we get our maximum value right here, because obviously that has a higher value than this guy over here, and this has a lower value than all the other ones. So there's my relative maximum on the interval. There's my relative minimum on the interval. This part of the graph is not in the interval because I went from -4 to 0. This guy's not in the interval because I went from -4 to 0. So from right here to right here is my interval itself. And you can see there's the minimum, there's the maximum value on the interval. So it ended up working out exactly the way that we did it. So thank goodness for us. So that's how you do it. Take the derivative, set it equal to 0, find the critical numbers, then set up the chart, do the left endpoint, all your critical numbers that fit in the interval, then your right endpoint, plug them into your calculator or figure out what their values are, and you're good to go. And all you have to do is make a decision. Which is the biggest number? Which is the smallest number? And those are going to be your relative minimums and your relative maximums. Piece of cake.